Good news for everyone out there in Bulldog Land. I was going to sing the entire Monty Python spam song for you, substituting span cleverly. But I've been told they would want, what do they call those again? Royalties. Royalties, yes, we don't like to pay those. So good news for you, you don't have to listen to me do that. I got others though. Span the Man Stasiak, that would work. Someone else will get it but me. Anyway, I will now concentrate on span because what we're going to want to do one day is connect a network analyzer or something that is much more commonly called a sniffer to one of our switch ports. And a common situation is illustrated here, and we could say I want to analyze traffic sourced from these three PCs. I could say I want traffic, sourced and destined for those three PCs. And to get that job done, of course, the analyzer needs a copy of every frame the hosts are sending in or receiving. That's up to us. And we will use span to capture that traffic. Now, when I say capture, I don't mean grab it and bring it over to the analyzer and it doesn't get to the destination, because, of course, that would just be a tad counterproductive. What we're doing instead is span allows the switch to mirror traffic from source port or ports to a destination port, and it's the destination port to which our network analyzer could be connected or would be connected. Now, I could use a laptop with network analyzation software on it. Of course, there are huge dedicated devices that do nothing but analyze traffic to the nth degree. But either way, we've got to mirror traffic to that network analyzer. What we're running here is called local span. And the source and destination ports are on the same switch or the same logical switch stack. We've talked about switch stacks in other videos, and if you make a logical switch stack out of multiple physicals, of course, that is still considered local span. By default, both traffic destined for and sourced from the source span ports are mirrored to the destination port. Now, the command monitor session starts a span session along with defining the source and destination ports, and we're going to do some local span here in just a moment. Now, multiple span sessions are totally separate operations. So you can define multiple span sessions, that's not a problem. The limit depends on the switch platform that you have. Now, Cisco 2950s allow only two, and sometimes that's plenty. The one that I was using here when I wrote this particular chapter was allowing just a few more. It was allowing 66 span sessions to run at one time. That's a lot of spanning. So let's go ahead and set up a local span session, and let's bring the equipment up. We'll go with this switch to start with. Actually, let's go over to switch 1. Ta-da! And again, the command is monitor session. And on this particular switch, we can run up to 66 of them. We're going to run one. I'm going to put number 47 because I get tired of putting one all the time. You can see that we can define the span destination interface or VLAN. Span filter VLAN. We're not getting into filtering in this course. And we've got then the source, the span source interface or VLAN. So we notice it's mentioned a couple times that we could use a VLAN for the destination or the source. And something I wanted to show you here, a couple things. First off, I don't need to run show VLAN brief because it doesn't matter to span whether the source ports are all in the same VLAN or not. It doesn't matter. Possible sources, and we'll see this in the iOS help on the live equipment in just a moment, but they include individual ports, that's the most intuitive, entire VLANs, and we saw that. You could say, source VLAN 5, whatever, whichever VLAN you wanted. If you're doing that, you're running what we call VLAN-based span or vSpan. And possible sources also include port channels, and that, of course, is our representation of an entire ether channel. So a lot of different kinds of sources we can use here, and we will put source here. And you can see we've got interface, something called remote, which we're going to look at in the next video, and then VLAN. And then interface fast, and I'm going to do 0, 3 through 5 for that statement. And now that we have a source, we need a destination, and assuming fast Ethernet 0/9 is where our network analyzer is attached. Of course, you got to use the same number there. And we're going to do interface, fast 09, And you got the, you have the option there to use the comma or the dash if you want to put some more interfaces there, that kind of thing. But we're just going to stop right there. And that's it for local span. Congratulations, you just finished your first local span configuration. And we run show monitor. And it's going to give you the information. It's going to tell you your session number, what type it is. You can see here it even defines a local session. Source ports are fast Ethernet 0, 3 through 5. Shows you your destination port. Encapsulation and ingress we're not concerned about right now. We're mostly concerned about the information there at the top. And that is it for local span. One thing I want to show you here, though, I usually lead up to this with a little dramatic introduction because I'm about to save you a lot of troubleshooting time. Because people will go back and they'll monitor their port, they'll look at their ports that they've set up span, and they see this. And they go, oh man, you know, something's wrong. And the eye only goes as far as that. And it's like, oh, you know, my interface is down, my line protocol is down, my span's not working, what did I do wrong, etc. You didn't do anything wrong. This is actually the one time when you expect to see this, and this is actually the expected and desired behavior, as I like to call it. You actually expect to see this when you have an analyzer connected to a port and you have made it a span destination port. Here's the part that's really important, monitoring. That tells you right there you are looking at a span destination port. So don't try to troubleshoot it because frankly it doesn't need any troubleshooting at all. We looked at the options there for local span, and that's all well and good. You know, but what if span isn't all local? We know that that is not always going to be the case. You're not going to be able to use local span all the time. What if the traffic to be monitored is originating on one particular switch and the only vacant port available is on another switch? Well, this is where RSpan to the rescue. Configuring remote span on both switches. Every switch in the path here has to be configured for remote span. And here we only have 2 switches, so they both have to have remote span on them. This allows mirrored frames to be sent over the trunk via a separate VLAN that will carry only those mirrored frames. Now, this is not a complex configuration. It's even simpler than it used to be, but we do need to keep just a few things in mind here. Pardon me. First off, if there were intermediate switches between the 2 shown in this example, they would all need to be RSpan capable. So if you've got 2 more switches between these 2, they've got to be able to run remote span. Now, VTP, it treats the RSpan VLAN like any other VLAN by propagating it through the VTP domain, if we configure it on a VTP server naturally. Otherwise, that VLAN has to be propagated manually on every switch along that path. VTP pruning is going to work normally. It will prune the RSpan VLAN under the same circumstances it would prune a normal VLAN. And MAC address learning is disabled for the RSpan VLAN. The source and destination ports must be defined on both the switch containing the source ports and the switch connected to the network analyzer. But the commands are not going to be the same. They're not going to have the same values in them, I should say, so don't cut and paste because we are not looking for an exact copy of the config on these 2 switches in question. After that, you know, all the config is pretty easy. I tend to mention, and I would have mentioned later, but I'll pop it here now. The hardest part of span, if there is one, is remembering what ports can be source ports, what ports can be destination ports, and the little rules for the RSpan VLANs. The actual configuration is very straightforward. Here's what we're going to do in the very next video, the setup for our RSpan VLAN. We're going to have 1 switch. It's going to have 5 source ports. And we're going to have trunking set up between the 2. We're going to create VLAN 30 as the RSpan VLAN. And over on our other switch, our RSpan destination port is going to be fast 0/10. We'll make that happen and go over a comprehensive list of what ports can and can't be source and destination ports in the very next video. I'll see you there.